Hey everybody, how you doing? It's Mr. Terry. I'm sorry that I'm talking quickly, but this lesson is going to take almost the total amount of time I have to record this message, so I'm going to get started right away on the rock cycle. Here we go. The rock cycle. Stop. Somebody remind me what a rock is. A rock is a naturally formed solid made from one or more minerals. But wait. Stop. What is a mineral? I don't know. Well, I do know. You may not know. A mineral is a solid or inorganic substance of natural occurrence. This means it occurs naturally in nature. It's not made by people. That has a definite chemical composition. So when you think of chemicals, think of the periodic table and think of all the elements on the periodic table. These rocks are all made of different types of elements on the periodic table, and for every different type of rock that you see, it's made of different elements on the periodic table, and that's what gives them their color, their texture, and what we use them for in the real world. All right, moving on. Slides moving slow. What is the rock cycle? The rock cycle is this continuous process by which rocks are formed and changed from one form to another, or destroyed and then formed again. And the concept of the rock cycle is attributed to this man, Mr. James Hutton. He lived in the 18th century. He was born in 1726 and died in 1797. And he is considered to be the founder of modern geology. And his nationality, the place where he was born, was Scotland. He's a Scotsman. He's a Scotsman. That's right, he wears a kilt. Did you know that the national animal of Scotland is a unicorn? You know, in the United States, it's a bald eagle. That's cool. But in Scotland, a unicorn? Do they think unicorns are real in Scotland? I don't know. We'll have to ask one. If I ever meet a Scotsman, I'm going to ask them if they believe in unicorns. All right, moving on. So, what I want you to do real quick, and I'm sorry I didn't tell you at the very beginning. I want you, when I say to pause this video, and I want you to go get a blank piece of paper and a pencil. And if you have some map colors, crayons, or markers, get those too, but if not, it's okay. You need one blank piece of paper and something to write with. And I want you to draw this whole thing very quickly, just a quick little sketch. Make sure you can draw this little volcano, but write the word magma. Draw yourself an igneous rock. Make sure that you draw the little holes that are in the rock. This is important. I'll explain later. This is sediment. This is going to look like gravel, sand, dirt, soil, tiny, tiny pieces. I'll explain more why sediment is in the rock cycle. Draw this sedimentary rock. When you draw sedimentary rock, make sure that you draw these lines and these layers. Layers. Ogres have layers. Draw these layers. This is important. I'll explain more later. And the last one that I want you to do, and I don't want to get too close, but draw that one. This metamorphic rock. Not all metamorphic rock looks like this rock, but you can see how the pieces, the different colors in that rock, have been squeezed together through very, very high pressures. And more about that later. So I'm going to pause the video, get your paper, draw this real quick, and you can take some notes. Go ahead, go. Okay, hopefully you went and got your paper. If not, I tried to help you. All right, moving on. So the first rock we're going to start with is igneous rock. And we're going to start with melting. Melting rock, igneous rock, is formed when magma, not lava, magma from a volcano is crystallized. That means it's kind of like turned into a solid through melting and cooling rock, and that forms igneous rock. And when you think of igneous rock, you're like, why does it have these holes in it, Mr. Terry? Well, think of boiling water. When water is boiling on your stove, it has these bubbles. And what is that stuff that rises from it? Well, that's steam. Steam is a gas. Igneous rock is liquid rock. It behaves basically the same way that boiling water does. And as the rock is liquid, there's gases that want to escape. Well, the rock can cool so quickly once it's out of the volcano that the little hole that's left over, the little pocket of gas that's escaped into the atmosphere, it will solidify, it'll crystallize just like this and form these little holes. And that's how igneous rock is formed. And you can see basically any rock you see that has these little pockets in it, almost any rock, is going to be a type of igneous rock. Igneous. All right, next one. This is a scientist, a geologist more than likely, or a volcanologist who studies volcanoes. He is getting a sample of magma from a volcano. You can see that he's dressed in this thermal protection gear. This keeps him safe from these dangerously high temperatures, probably 1,500 degrees, 200 degrees, maybe even hotter. Also, remember those gases we talked about? There's gases that escape this magma. This magma comes from deep within the earth. And you don't want to be breathing these poisonous gases. They will kill you. So he or she has this oxygen tank here so they can breathe clean, fresh air and not breathe those dangerous gases. And this is the collection tool that they use. It's got like an extender, and they can stick it down into the lava, scoop it up, and take it back to the lab, because scientists are very interested about the material that comes from deep within the earth. They're still studying it to this day. They don't have it figured out yet. Not everything that they want to know. All right, moving on. So some types of igneous rock. I'm going to move through this quickly. We have pumice, that's used in pencils and pencil erasers and foot scrubbers. Obsidian, that's for you Minecraft fans. It's also used in jewelry. Rhyolite was used by the indigenous American Indians to make their arrowheads out of. Diorite is used in construction and brick pavers for your garden. Andesite is used in making tiles and sculptures. And this stuff, scoria, is also called lava rock sometimes. And people put it in their flower beds, and they like to decorate their lawns with it. They think it looks good. But it has a name. It's called scoria, and you can see the holes where the rock was cooling and the gas was trying to escape. Okay, moving on to the next part of the rock cycle. Heat and pressure is our whole explanation for metamorphic rock. Metamorphic rock. Metamorphic rock is a type of rock that is formed when either igneous rock or sedimentary rock, which we haven't talked about yet, but that's okay, when they're put under intense pressure or heat from deep within the Earth's crust. Now let me talk about this pressure. If you have ever gone underwater, really, really deep underwater, at a pool, in a lake, wherever, and your head started to hurt, your head was feeling intense pressure from the weight of the water pushing on your skull. And the gases that are in your body want to escape. They want to go up. They want to get out of the water, right? Well, think about rock, either igneous or sediment, that has got the entire weight of the earth sitting on top of it. It's squeezing it, squeezing, and it's deep, really deep underground, hundreds of miles underground. And so there's lots of heat and there's lots of pressure. And it forms this type of rock, metamorphic rock. Morphic means to change. So this rock is constantly changing, especially when it's deep underground. It's moving around because the things that are happening underneath our feet it's not still underneath where you're standing right now or sitting if you're listening to this. The things going on underneath the earth are constantly moving. There's this convection happening underneath the earth. All right, so that's metamorphic rock. So here's some examples of metamorphic rock. I'm going to go really quick. Granite is used in kitchens. Gneiss is used in flooring and tile, which is in your bathroom. You probably recognize that pattern. Basalt is used to make concrete. And greenstone is used in jewelry and tools. All right. Now we go to pressure and time. Pressure and time is the name of the game here, and that's how sedimentary rock is formed. A rock that is formed through the accumulation, compaction, and cementation of sediment. Cementation is going to be like cement. Look at the root word cement. You know how cement is liquid at first and then it kind of solidifies, becomes hard. That is how sedimentary rock is formed. And here's the important part about sedimentary rock. This is what I want you to notice. See these layers? These layers form over time. Lots of time. And that's basically the name of the game with sedimentary rock. You get these layers that form. And the next thing I want to show you is a cutout of a mountain. Now, normally you wouldn't be able to just look at a mountain and see this, but there was probably some kind of geological process, an earthquake, possibly erosion, that caused this section of a mountain to become exposed. But it's great for science because you can see all the different layers in this sedimentary rock. Now, here's the cool part. This is like a time capsule. Up here, this layer, that's not very long ago. That could be 100 years ago, 200 years ago, maybe a little longer. But the deeper you go, the further down you go, you can go back. Here, this could be millions and millions of years ago. This could be before the dinosaurs were around. Because if you dig deep enough in the earth and find dinosaur fossils, you stop finding them at some point because we know dinosaurs weren't always on Earth. There were different forms of life before dinosaurs. So if you dig, you're going back in time. And that's what I think is really cool about sedimentary rock. And this is where scientists dig. They dig in these layers to find fossilized remains of life that used to live on Earth. All right, moving on. Examples of sedimentary rock. I've got to go fast because I'm going to run out of time. We've got limestone used in paint and toothpaste. Yes, toothpaste. Sandstone. Sandstone's really cool because it dissolves in vinegar, which is really awesome to see. It kind of bubbles and fizzes. And slate, which is used to make bricks and pottery. Sedimentary rock is obviously where fossils are found, and also it is where geologists dig for oil. Oil that is used to make gasoline for your car, or any type of fossil fuel, petroleum, natural gas. And that is a diagram of what it looks like. That oil rig that you see out in the field, there's a lot going on underneath it. So I'll let you zoom in on that on your own time. And I'm going to move on. So here's a really important part, and I'm sorry my arrows are off right here. Rocks can be formed into each different type of rock. The rock cycle is not a circle all the time. Okay? An igneous rock can be worn down through erosion and turned into sediment, and then those layers build up over time, and they can turn into sedimentary rock. Igneous rock can be pulled to the center of the earth and have that pressure squeeze upon it and turn it into metamorphic rock. Igneous rock can be remelted by heat from magma and turned back into a liquid. And the same goes for all of these. Sedimentary rock can be turned into magma and then cool into igneous. Sedimentary rock can be brought down to the center of the earth through volcanoes, earthquakes, and it can be turned into metamorphic rock. So each type of rock can become another type of rock at any time. It is not a circle. All of these rocks can become their own different kind of rock, or their own, each of the three types of rock. And that is the end of my lesson. That is the rock cycle. Here's a great picture of it, and I hope that you have learned everything that you need to know for this subject. And I'll talk to you all soon. It was good seeing you, good talking to you, and have a great week, everybody. Bye.